tell us your name, please.
Hi, I'm Stephen Gilly. This is our handheld detector right now.
My name is Sergey.
James.
I'm Chris.
Nice to meet you all. Can you tell us a little bit about what your project is?
So what we've done here is we've built a handheld radiation detection system. It actually includes all parts of what you need to detect radiation events. That includes the whole handheld that you see here, the detection diodes we've made, the preamplifiers, and as well as all the circuitry. And in addition to that, the final part of the project is being able to interpret those detection events, and James has built the Android application that allows us to do that.
Can you show us a little more about your working prototype and how it works?
So this right here is actually our working prototype. Unfortunately, we can't actually demo it for you without bringing a radiation source into the building. I don't think anyone would be happy about that. But what you see here is 2 detection pixels. Those pixels contain a diode on the other side. That diode is sensitive to neutron radiation that comes from this direction. So this is the surface of which we want to point the detector towards. The circuit you see behind it is the motherboard, and that motherboard contains all the functions that we need to catch those signals, identify which diode received that signal, and then pass it on over the Bluetooth radio, which is actually hidden behind this battery, over to the cell phone application James put together.
Is there something like this out in the market?
Yeah, so one of the motivators for this project was to do something that is cheaper than the current market alternatives. The current competing product is a blood hole detector. It uses a helium-3 gas proportional tube to count detections. That one comes in at $3,500. It's much larger than ours and much more expensive compared to this one, which we put in terms of cost at $390.
That's why your prototype is better.
So I guess the biggest advantage we have is really cost. In certain applications where you want to just determine whether or not a source is radioactive, we can achieve that much cheaper. We can tag GPS coordinates on it. We can provide the count rate in a number. So in that sense, we're paying a fraction of the price. That's where our advantage is.
Great. How is this prototype different from the senior design landscape?
So there have been a lot of changes that we made to this prototype compared to the senior design one. Our first prototype can only support 1 detection diode, whereas this one supports 9. And to do that, we actually had to overhaul the entire system. So the previous design was not scalable at all, but now Taven has done a lot of work to develop the new motherboard and microcontroller system that can support expandability far beyond this 9 diode array that you see here.
Fantastic. Do you foresee any future changes or possibilities for this project?
One of the possibilities that we have now is, since this is really a modular and a scalable design, there's a company that provided the initial investments for this project already called Handheld. They're already interested in us making strips of these detectors instead of 9, 150 at a time. They plan to line a game and put them in points of entry to the country, such as airports, where you'd be able to pass through and we would know whether or not there's any radioactive material on you at the time. So that would be the future for this project.
Great, thank you very much.